So hello guys, turns out I could not sleep and I am back again to the problem. And while I was away, I was making a tea for myself, and during that I had I was thinking about the problem only, and I feel fresh now, and seems like I can start working on this with a fresh mindset. Alright, so what I need at the moment, I need my pencil. Just a second. I'll start the broadcast. Correct. So, quick heads up. So, those who are new to the channel, uh, I'm gonna tell you that this is how we solve. This is the channel where we solve daily lead code problems, and today I'm solving today's lead code problem. And this is basically a live attempt. So I've read the problem in the previous live stream, but here I'll be repeating it. So what the question is about? The question is about we have to find the most profitable path in a tree. So we will be given a tree and we have to find the most profitable path. And there are two. Let me just explain the question to you. So we will be given a tree. Let me just create a tree. The tree is special. Let me just delete these pages so that I can work on these individually. Cool. So this is the problem here, right? Correct. Okay. Let me use it in a vertical manner. I hope it is fine for everyone. Me as well, it is fine. It is better actually. So I'll keep this microphone at this point. Wait. Correct. So this is there. Yeah, now I'll tell you what is the problem statement about. So I'll use some different sort of color like red. So what is the problem here? We have been given a tree. The tree could be like anything, but you should notice that it has only n minus 1 edges. What does this mean? If there are n nodes and there are only n minus 1 edges, it means that no cycles in the tree slash graph. Basically, the basic fundamental thing of tree is that there are no cycles. Okay, so which now the question says there are two people. One is Alice, which is at the root node, and the root node is valued 0. And there is a guy named Bob, which could be anywhere. Let's say Bob is here at any node, right? And there is a movement pattern. Alice goes down, Bob goes up. This goes towards root node, right? And this goes towards any of the leaf node. So what I thought back then while I was making a tea is that the path of Bob is fixed because Bob have to make a step above, and to reach to this node there is exactly one path. Since there are no cycles, there is exactly one path in which Bob can go up. So at each point of time it is defined like what is the impact that Bob has to do if Alice tries to traverse this path. And this is dependent on time because this will be activated at t equals to 1, this will be activated at t equals to 2, and this will be activated at t equals to 3, right? And here t equals to 1, t equals to 1, t equals to 1, there are three options. So yeah, so what I figured out, basically there are these leaf nodes where Alice can reach. While traversing this, I'll run a DFS to reach at these nodes, and I'll maintain how much cost is incurred at reaching each of these. While doing that, I'll do another thing where I mark up things that how Bob has progressed the time. So if I'm traversing for Alice and if I notice a node where Bob has traveled, I have to subtract some values, right? Let me just explain my approach to this particular problem. I think you guys cannot see the values which are there because of the dark screen. I'll write them up. Here it is -2, here it is 4, here it is 2, -4 and 6. First thing first, I will change this to a better structure where root is at the top and 1 is here. Then we have 2, then we have 3, then we have 4. Bob is at 3 and Alice will be here only. So what I am saying is that path of Bob is already decided. It will be here at t equals to 1, it will be here at t equals to 2, right? Or if we know the depth of this thing, we can say that. But yeah, we also need to know the nodes which are actually part of Bob's traversal. So we need to like do kind of a BFS or something. So but we need to store this. The time at which Bob reaches and the time at which and the like time at which Alice reaches. So this is Alice. Alice will go. Alice will have these many options. This is option 1. This is option 2. Alice have two options. Both of these. So for this option, I'll say that this is t equals to 1. This is t equals to 2. And for this one, this is again t equals to 1 for Alice. This is t equals to 2 for Alice. This is t equals to 3 for Alice. And obviously this is t equals to 0. This is t equals to 0 for this Bob guy. So notice this. If I calculate of this path, let me use some other color, which is this one or yellow one. So here you see, here t equals to 0, t equals to 2, t dash equals to 2. So who will reach earlier? Alice will reach, right? Notice the value of it. So add a -2 through the Alice path. Then you come here, you see t equals to 1 here, t equals to 1 here. It's a tie, right? So what happened? The scores will be shared to both of these. So Alice gets +2 because it was 4, okay? And at this node, the value is 2 and Alice can reach here, Bob cannot. So this Alice got here completely, correct? Now if I talk about this path, so at t equals to 0 it will be -2, correct? And then I go to this path, t equals to 1, this is a tie, it will be a +2. Here also it is here Bob has 1. This has already been unlocked, so this is a +0. And here they get a +6. So this is clearly a winning one with overall cost of +6. Right, so it feels very good to see that the logic which that come into my mind. And guys, I was actually not thinking about it while I was making tea. My subconscious mind was working on it. Now let's come on this one. So here it is a simple problem, 0 to 1. Bob is here and Alice is here. So t equals to 0 for Bob and t equals to 1 for Bob. T equals to 0 for Alice. T equals to 1 for Bob. So obviously this has 1 by Alice, so it is -7280. And this has 1 by Bob, so here Alice gets 0. So the answer is this one. So the algorithm wise we are good. However, if I tell you the algorithm, this is the algorithm. The algorithm says for each node we have to create two variables. First it visited and time by Bob. So this will be true or false, and this is the time at which Bob visits. Then this will be initialized as false and -1 previously. Now from root we do a DFS. If it is visited by Bob, compare T with T dash. If equal, divide. If T is greater than T dash, Bob takes it. In that case, we have to do nothing. Else, Alice plus that node, right? If leaf node, save in a minimum answer variable, which gets updated with each and every save. So now this is the algorithm. This is obviously this is order n only, and this is order n plus m, like whatever it is. Like this is just simple DFS logic, which is, I think, if we maintain a, yeah, DFS thing is great. Actually, for that we have to maintain a visited one. Should we do that? Correct, yeah. That DFS code I can write. So now let's jump to the code section. And guys, trust me, I haven't seen any solution. This was my subconscious mind which solved it. When I started thinking about how B will move, how A will move. Earlier it was quite haphazardous, but over time I get used to the problem, and then it started getting formed as a map in my head. So for the code purposes, we need a structure, right? So we will be given edges in arrays, right? But what we need here is that we need a adjacency list or something, where we can say, like, one, say where is the path connected, which nodes are connected, then two, say which nodes are connected, and then we maintain that parent thing wala thing over there, because it is a undirected path, undirected graph, right? So that's the thing, like we have to work in that way, right? So this is the adjacency list we need to create first. Basically this is the graph graph nodes which we talk about. This is vector of int in that way. And then what we need to do extra here is this. After adjacency list, we need to have a map of integers, which is the node and that thing, pair of bool comma int, where this will be for time, state as, and this is basically true. To initialize this, after this, what else we need? After this, we need a DFS function which starts with zero cost or like the first cost. There are always multiple options to which we go, and there are some nodes have no children, or like the only children they have are their parents. So we need to have the node, its parent. This is the running cost. Yeah, this is it, I guess. Entirely we need this only. So I have to code this logic up in the code editor. And yeah, I think it's fine, man. Because I'm really sure about whether this can work or not. Because this logic, if visited by Bob, we have to do this and other stuff. I feel very confident in it. For the for the reality check, I'll just check if I am live on YouTube or not. Ignore the recommendation, guys, because this ID is used by many people in my family. For the reality check, I'll just check if I am live. Yeah, guys. So this is some sort of reality check. Anyways, I have to move to this problem, and here I have to solve it. Before we move ahead, I'd like to change this big bulky names to something else, which is E. Bob is cool. This can be changed to AMT. Yeah, this AMT is required to access where we are going. That is fine, no problem. So we have an answer defined with us, which is -1, and we maximize it as we go ahead. Correct? Okay, so our answer can be very low as well. It should not be -1. It could be like -780 or something, right? Because the values which are there, amount I is in the range of this. So 10 to the power 4, 10 to the power 4, 10 to the power 4, 10 to the power 5 times is actually 10 to the power 9. So I can use some different values like 111, which is actually a long thing. Doesn't matter. Now what I need to do, I need to create a vector. So we have been given this E thing. This is cool, but it is not of index type. So first I need to have n with us, which is E dot size, which is actually amount dot size. Right, so we need to have a vector here, vector of int. Since the nodes start with this is basically a graph, n and vector of n, so we don't need to initialize this is fine. The size is defined as n, right? The graph size, and obviously from 0 till n minus 1, that is the indexes. Now if I go to for auto x inside E, we have another vector I equals to x of 0, integer j equals to x of 1. Then we need to do this g of, this is an indicating an edge between the two nodes, right? So g of I dot pushback j and g of j dot pushback I, right? And also I need a map which has to be initialized. Let me create that map over here. That map is of integer, pair of integers, pair of integers, which is actually this is map for B Bob, right? I'll call it MB, map Bob. Right, so this is the first thing first. This is the vector which we have, and this is the map which we have. Correct? What else we need? I think we are done with the basic things here. We define this, we have to initialize it, and then we have to write the code for the DFS. Okay, for initializing thing we have to go in. This false, not visited, and this is the time period T. Yeah, now I will be going up, 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 and up. There's a fundamental problem, man, which is if I go up at this node, how do I know that this goes towards the root? Because there are multiple options, right? If you go by children level, there are multiple options. Even if I go downwards, let's say for example, B is here, B is here, we are going here, right? So we can find what children this node has. How can I identify who is the parent of this one? Because there are these three edges, and because how can I decide which node will take me towards the up level? For this, I really need to have these things sorted, because if I do it from the top, I know that these two guys are at the depth 1, these four guys will be at the depth 2. If I start here, it will, yeah, mark these at depth of 1 only, but this will not take me to this point. This is 1 again. This is cool. 1, 2, 3, 4. Ultimately, I can reach to this point. That is fine. But this path, how can I? So for one and all, I'll do a DFS and I'll mark the whatever is the time taken by this guy, right? Then I can do this because I have to go just one level up. Out of these three children, I have to find the one which has. Doesn't it look like complicated stuff? Why to make it complicated? Because this is an undirected graph, to be honest. There is no clear mention. Yeah, because we will be given just the edges. So how do we know that? How do we flatten that graph? For that, we need to have some kind of approach. Like we have to use some sort of indicators. If we use some sort of those kind of indicators, basically we have the depth for each of the nodes. That we will be doing a DFS from the root node till all the places. And the moment we find depths of each and every one, here we can also calculate the cost, but that is fine. First we need to do this thing. Creation this required very much effort. So this is fine. We will have a map which stores this. We'll also have a map of visitors, depth, depth of n. This will work as a visited array as well. So what if we add everything to this? What if we add everything to that? You mean do the computation? I need to prepare that map first, then I can just go with flow to compute other things. Right, so now we have to do a DFS. This DFS is a basic DFS. And then compute. Guys, this time is really dangerous. Then compute amount. Then compute this final logic, right? Okay, let me write DFS1. How will we start this? This is the node number. Then we have the, what do we need as the visited array, which is depth. Right, this is the node. When do we know it's an end? This is the graph we need, and then we need this map. Where do we need this map? I don't think we need this. Depth and G. Okay, so this is an array. Better I'll use a vector now. Here I can assign this to -1 right there only. Okay, so now what I need here is basically I'll use an ampersand to avoiding the copying of data structures, data arrays each time when recursion loop is loaded. So base case is here. If node we go to a higher node, then we see if it is an end or not. Yeah, so first thing first, if node is greater than equal to n, then you have to break it. Not break, basically you have to return. Otherwise you have been given the depth. Depth you have been passed. So here this 0 is at the 0 depth. I'll do that. Depth of 0 is 0, right? Now, how do we know this is the edge case? This is the last where we have to. So if yeah, this g of node dot size is equals to 1, this means we are at the leaf node because there is no other node than the one which have traversed really. That will be automatically handled. Let me tell you how. So we are at this node, right? We are at this node, correct? So we have to mark the depth of it as 0. Mark कर दिया. Then we have to do this for auto x inside g of node, these are the children. If depth of x is not equal to -1, then that is probably visited. We have to continue. Otherwise, what we have to do is we have to make a DFS1 call where we go to the next node, which is your x, right? This will be d plus 1. Then we have depth, then we have g. By this way, we created the depth thing, right? Now we have to compute MB. For that, we need to start from Bob, go to the parent of Bob, right? We need to go to the parent of Bob and do that basically. Yeah. So we are at that place until and unless we reach the node, root node. So let's say it is a current node goes to Bob while current node is not equal to 0. What we have to do? We have to find parent of Bob. So for which are at the top level, like Right, well, we have the depth of Bob. So we have integer current depth. So the depth of Bob. This is the current depth for auto X inside G of current node. What we see here is that if depth of X plus 1 is equal to current depth, this means that this node is the parent of this particular node. What we have to do is we have to update these guys over there. Yeah, I can do that, don't worry about that. We also have a time variable t equals to 0. What will happen here? So basically we have to do this mb of power is equals to true comma 0 t. Right, now t has been created to t equals to 1, right? So this is the case here. We found another children. So what we do is current node equals to x, current depth equals to current depth gets reduced, right? And what happens to the t? We also do this mb of this x node is actually, and t is here, then we have t plus plus all the way up to current depth has been reduced, current node has been updated until we reach to the 0th node. So we reach the 0th node, and then yeah, this will set everything up. Now we have that MB computed. Now we need to write DFS2, which actually incorporates the logic, right? Uh, which actually takes into account the leaf nodes. There will be probably a copy of this, and we need another widget kind of stuff here in order to in order to keep track of what has been visited and what has not been visited. So I can just use a visited array over here, and here I'll do one thing. Basically here here what I need to do is basically I have to define dfs2 where we pass how we would go about this. This is dfs2. The moment we spot a node which is at the end, we do some of our computations. Correct, we do some of our computations at that point. What sort of computation? We have a running variable, right, which shows the current answers, which you are right. So uh, this is a very big code, and it is going to be a very big code actually again. So this is the DFS2. These are the nodes which we will go about. We are not gonna hit this because we are not pushing it actually in any manner. So here we have this, instead of depth we have a visited one which is initially -1, right? If it is not equal to -1, then it means it is visited. So here is the visited, and this is also visited. Now what I need to do here is that Guys, I need to check. So basically we will be passed the root node at the beginning, correct? So this is the root node, which is 0 root, and then we have n, correct? Then we have the time t. So we are starting at t equals to 0, and then we have mb, and then we have the graph. This is what we need, and also we need the answer, right? So here we have t answer mbg. T answer mb and then g. This is mb and this is g, and I have to add t answer, and integer t is required, basically the time, and here we have the answer. Node nt, let me check. This is node nt answer mbg. Correct. So this is basically we are marking it with 0, means visited. So this is actually DFS2 if it is a new node. Right, and then we have to compute things actually. So what should we compute here? We should compute t is given to us, right? Compute answer. Compute answer. Answer is for reference. Like first we should have the running answer, which is basically your t is the time, right? And this is the sum, which is initially 0. Here we have answer से पहले you'll add this sum here. Answer से पहले you have this sum over here, right? So we have to compute sum first. So one thing here we need to do is that um, the sum is given to us. For the first guy we have to unlock it, right? And then we have to pass it for the next guy. So here if we just compute the sum plus equals to, also I need this particular amount array. Wow, there are a lot of variables, man. At the end I can have this amount, and let me just paste it up. So how we do this? Just do this amount of node. This we should have done if we were sure about that. There's an if else statement, man. So what if t, this is t equals to 0 or whatever it is. If t is equal to t dash, then that's a different case. T dash, which is like mb, mb's node is false. Just do this amount uh, node is equal to second part of it. If it is greater than, means B is reaching here late, right? Correct. Fine, this is fine now. Yeah, that could be compromised with a single if statement, but yeah, this is fine actually. Now we calculated the sum. Now we are going to x, n is there, then we have t, which is t plus 1 obviously. The sum is sum obviously. The answer is answer. Visited is visited. MB is there, then G is there, then amount is there. This we have to do, right? Now one thing here, I need to know how many children it has. NC equals to 0. And if we spot any children here, do NC plus plus, right? So we go to this particular loop, right? And at the end, if NC is equal to 0, what we have to do is to answer equals to max of answer and sum. This has to be there. So this sum should be actually a long, right? This is the case. Answer should be maximum of answer comma sum. Correct? There is no matching function to call. Okay, so this is actually a long, actually long only. So what we have here, long sum. Do we have long sum here? Okay, where is MP? This should be MB. We got some more errors. Redefinition of T. Yeah, so I think T was limited till there only. I'm missing some arguments. Expected 9, we have only 8. Correct, here is 9. Wow. Node NT sum answer. Node NT sum answer. Then we have visited MBG amount. There is no visited MBG amount. Okay, finally we are getting some wrong answer. In the cases we got some weird answers. Proud of myself. Let's see. Let's see how it's happening. Okay, so what are we doing with the answer variable here? This is the answer variable here, correct? We're returning answer here. Can I do this because I want to do it? I pass it by reference. This sum as well has to be a single variable which is maintained over time, maybe. See this, how genius I am, man. You see, this is this is really crazy, man. I took so long to figure this out, and the code is also too long. I would have wanted a cleaner code than this. And guys, I have to learn the cleaner code and modify my approach and learn from that mistake in order to progress. Correct? I'm making fool of myself. I have to be a little aggressive and attack these questions. Anyways, this is cool. Let me just check if it passes the solution or not. But there can be multiple hiccups. If I check, I would be able to avoid it. So this is the first one. If it computes depths in a proper way or not. So this is a standard DFS code which I'm sure of. This is kinda visited. Since we are going down, the depth will increase. And what we have done here is basically we have gone up. So the depth will decrease, whatever depth it was here. This is at t equals to 0. I can't tell you how I feel because it is too good to see this daily streak, daily streak, but the solution is very poor. It is actually order with submission length exceeds limit. Yeah, the code is actually too long, and you see how many variables I have used. Yeah, this is on the spot solution, man. I have literally I wanted to solve this in order to avoid today's streak to get ended, like to get lost. If I check the best solution, which is probably over here, it won't make sense, I know that, but are these codes long as well? Wow, quite long actually. Let's see this one, which is not that long. So they have this adjacency list, and distance from Bob is computed. Where? Where is this from Bob? Here is this from Bob. Okay, they do a single man, they do a single DFS, but they have made it like that. Yeah, here is this distance from Bob and depth. Instead of time, they have maintained this distance from Bob and other stuff. Right? For that, we need to know that, right? We need to know the distance from Bob first. And then, no, they have just used a single DFS where they have done all of these things. Yeah, guys, so guys, this channel is not a best solution channel. This solution is for this channel is actually for my practice where I learn to solve unknown problems in a very efficient way. The strategies which I developed during this journey, they should be documented well enough. Again, it was a sad day, but I made it very happy. Yeah, and I'm satisfied to see that I was able to code it up. This was not a simple problem, in my opinion, because it had a lot of things to be figured out. First thing first, we need to figure out that this entire tree is a this entire tree is first we need to figure out that this entire tree is an undirected tree. What does that mean? We have to handle things on our own. About the like, we cannot access the parent, we cannot know the other things. So guys, basically I was blank on these topics because I had lost my grip on graph questions, but with this question I gained it back, because in undirected ones we don't get access to the like parents. We have to maintain a visited set or visited map with us. This question is really good, I liked it. And this part confused me a lot in the beginning, because I was thinking Bob can take multiple paths. But the moment when I realized that the path of Bob is fixed, then I started forming approaches how we can optimize the things visited by Alice. So this DFS1 and DFS2 could have been merged to each other, and this will be like, again, this will become a very short code. Yeah, because this is also using 90 100 ms of time, so I don't think mine is bad. Because of 2 times DFS, it is a bit long as well. Long for sure, right? If I try to optimize this a bit, mm, probably I can use a better visited set. I don't know, maybe I can. Cool guys, this is it for today's video, and I'll see you in the next one. Take care, goodbye, good night. Not goodbye, we will meet tomorrow, preferably in the daytime where my energy is up. Because guys, before this problem solving, I had a very hectic and very mind consuming day at work. Now it's fine. I'm very happy that I solved it. Although there is a first failed attempt that exists in the channel. You can say it. Bye bye, take care.